So we have the following question. We have two charges and then we have a distance of 0.57 meters between them. And then we're asked to find a point between these two charges along this line here where the potential would be 0. So the thing is, I can choose any point and just assume that that's where the potential is 0. And the only thing I'll have to do is I'll have to sort of find its distance. So if I choose that the point where the potential is 0 is over here, then I have to find x. That's that unknown distance of that point, which we're being asked to find here. So I could draw it that way, or I could also draw it on the other end and assume that the distance between Q2 and that point is x and work the other way around. Or I could also choose that for the point to be here and assume that this is x. So it doesn't really matter where you place the point, just guess, just make a guess. The guess doesn't have to be accurate. The idea is just that you need to be able to just draw out the point itself and then realize that you just need to assign it an unknown variable x. The x will automatically tell us the actual distance. Now the main equation we need for this type of a question is the potential at a point. So each of these charges has its own potential, okay, at various points along the line. And so what we're really doing is the way I'll solve the question is I'll start at Q2, so standing on Q2. I'll be standing on Q2 and then I'll walk towards Q1. So basically, as I walk towards Q1, I will feel a change in potential, which is delta V. And a change in potential in this case would be my final position would be at Q1. I would stop at Q1. So it's going to be final minus initial, which is equal to the potential of the first charge of Q1, which is minus the potential of the second charge. And now I'm just going to plug in this equation for each of those charges. And I know that the change in potential has to be 0 because that's what we're being asked. So it's going to be 0 is equal to kq1 over r. Instead of r, v1 is going to be from that point, q1 is at a distance of x, so it's just going to be x minus kq2 over r. Again, r for q2 is going to be a bit different. It's going to be this entire distance of 0.57 meters minus x. So as you get rid of the distance x, when you subtract x from 0.57, you get the remaining distance between Q2 and that point. So it's going to be 0.57 meters minus x. That's the radius for Q2. Now I'm going to do a bit of erasing and a bit of decreasing the font here. Now I'll rearrange the equations a bit. Now you'll notice something, that there are certain common terms that will cancel. The k will cancel and the negative sign will cancel, and the k here will cancel and the negative sign here will cancel. So these two go away. Again, I need to decrease the font. So we're left with Q1, which is Q1 over x. So Q1 is 52 microcoulombs. So it's kind of my advice for these kinds of questions. Just start with a general generic formula. Don't plug in numbers, okay? This is the more easier and simpler way of solving these questions, so you don't get confused. then try to cancel out common terms as much as possible, and then at the end you can plug in the numbers like I am right now. It's just easier this way to so that you don't get confused. So that's 52 microcoulombs over x, which is going to be equal to negative. Why negative? Because Q2 itself is negative, so it's negative 67 microcoulombs. Over 0.57 meters minus x. Okay, so look, again, before I solve for x, I realized that actually a few more things can cancel. Specifically the micro signs. The micro just means 67 times 10 to the negative 6, and the micro sign here is 52 times 10 to the negative 6. Since they're on opposite sides of that equal sign, they can cancel. So you can get rid of the micro, and that's going to save you from it will save you a headache when you plug things into your calculator. So now what I'm left with is 52 over x, which is equal to negative 67 over 0.57 minus x. And just remember that we've gotten rid of the micro sign, so now we're actually just dealing with 52 coulombs and 67 coulombs. So that means we're kind of back to the standard units, so we don't have to do any more conversions. Now I have to do some erasing to make more space. Now I rearrange the equation. I do a cross multiplication and I isolate for x, and then x should give me that value. So it's going to be 52 times 0.57, which is going to give me 29.64 minus 52 times x, because I'm distributing, which is equal to negative 67x. Now I want my x to be positive, so I'll move it to this side. So I'll get minus 52 plus 67, which is 15x, which is going to be equal to negative 29.64. And I'm going to do x is equal to negative 29.64 divided by 15. So that gives me the wrong answer. Give me 1 second to figure out what the problem was. So the mistake I've made, give me a few more seconds to figure this out. The mistake I've made here is actually very simple. This formula, v is equal to kq over r, is generally not really a vector, it's just a scalar. It doesn't have a vector form. Also, this formula is really an absolute value from what I remember, from what my teacher taught me. So what this formula really represents is just the magnitude of the charge, not the actual sign. Because the way my teacher taught it to me was that this formula itself is only accounts for the actual magnitudes, not the actual direction. So he once wrote it like this because he was trying to derive the formula or something along the lines of that. So what I did at some point was I plugged in negative 67. Though the charge is negative, we still plug in the positive value because the formula itself for the potential of a charge considers only magnitudes, not the actual directions. So the negative sign should go away. And now I'll get a slightly different answer. So give me a moment, please. We'll do 67 plus 52. So we'll get 29.64, which is equal to 119x. Because what I did instead was I moved negative 52 to that side. Okay, now I rearrange for x. You see how that small mistake just stopped me from getting the right answer. So let's see. So yeah, we're doing 29.64 divided by 119, and that gives us a value of 0.249 meters, and I hope that's the correct answer. And what do you know, it is the correct answer. So there we go. So really, the main thing to keep in mind about this formula is that it's an absolute value. Because of that absolute value, even if you have a charge that is negative, the negative sign gets cancelled out because of the absolute value symbol. And so this formula itself only represents magnitudes, not actual signs of charges. Of course, we deal with the radius a bit differently, like I explained before. And I hope this helps, and have a good day.